Welcome to Formwork and Excavation Calculations. Okay, so we have a worksheet here and we have a bunch of questions to find out. And let's get right to it. So formwork and excavations means formwork for concrete, which always means we need the center line perimeter. And then for excavation, we want to find out how much dirt do we need to get out, how many trucks do we need to pay for, that sort of thing. Let's have a look at the at our sheet here first. We don't exactly have a perfectly rectangular shape, but that's okay because we'll be able to move the walls out for our center line perimeter. And we're going to be calling them jog 1 and jog 2 as we move along to give them a name. We do have some dimensions that we can just add up to get our regular big total area. Then down here, we have more of a cross-sectional elevation view, as if we were making a cut right here and looking in one of the directions. So we have our wall. We see that it's 300 mils wide, 4,200 mils tall. That is the wall itself. Then we have a footing that's 250 high and 1050 wide. It's kind of hard to see. Then we have a slab that is 120 thick, and we have 400 mils of gravel subbase there. We also have an additional 600 mils of working room here around our wall. So that is by WorkSafe BC, it's the minimum standard. If we didn't have that, we would be working on the slope, or the slope could slough off a little and collapse into us or onto our formwork, all things that we do not want. Then we have the slope drawn in here. So we actually have a slope of 1 to 1, which makes it nice and easy for us. And we'll get to that in a little bit. And we have the height or the depth of excavation. Same thing, just different terminology. So 3.45 meters. So this line up here was the previous landscape, the natural landscape. And then the diggers came, dug it out to here, to the bottom of our footing. So we have solid ground. Our slab is higher, so we need to refill in some gravel and compact it because we don't really want a slab that it's 520 mils thick. That is just way too much and a waste of money. And then for our excavation, that will come in handy as well. Okie dokie, let's get right to it. For our center line perimeter, what we can do when we have jogs like this is basically move these walls out. For the center line perimeter, we basically want to create as much as we can a regular old rectangular shape. Because there's no wall out here, we can literally just move it out. Same dimension, same with this one, we can move it out. And luckily, we can do the same up here. We can move it out, and we can move that guy out as well. That is a terrible arrow. I'm really sorry. So then, let's find out our actual dimensions of our big rectangle. I always call it area of the big. All we need to do is add our dimensions together. So we've got 14.5 plus 7.6. I've been feeling a little dyslexic with numbers today, so I'm sure there will be some mistakes in punching them into the calculator, which is not a big deal. That is why we double check things. And then over here we have 15.125 plus 12.4. And we know that these measurements always go to the outside of the wall. 27.525. There we go. So that is the area of our big. So not the area, but like the dimensions of our overall rectangle to figure out our center line perimeter. Okie dokie, let's get it started. Page 1. Center line perimeter. Well, how do we figure that out? That is not in the picture. Here you go. Um, well, CLP, center line perimeter, is really just the perimeter of our formwork, except that we're moving along the center of our wall, right? So we're not on the outside, we're not on the inside, but we're actually just deadly in the center. So from there, we get a really nice and accurate measurement for our concrete volume calculations. So the way she goes is our regular perimeter, which is 2 times length plus width, minus 4 times our wall thickness. And always grab a calculator, grab a piece of paper so you can write along and get the practice of that. Well, now we're just going to add numbers to this. To 2 times length. Length is usually the longer side, so 27.525 plus 22.1 minus 4 times the wall thickness, and we know that that's 300 mils. Now, these numbers are in meters. Really, we should write meters in there. But we need to convert it to meters. So 300 mils, we know that that's 0.3 of a meter. Now we just punch her into the calculator. So 2 times, you can do all of this. Make sure that you add the brackets because your calculator follows the whole bed mass scenario and will give you different numbers if you didn't put in the brackets. So always remember those. You can also do step by step by step, or just do it all at once, however you please. So 22 times 27 plus 0.525 plus 22.1, close bracket, minus 4 times 0.3, close bracket, comes out with 98.05 meters, and that is our center line perimeter. This is a number that we will continuously use through our calculations. So we want to highlight it so that it's easy to find. And lucky for us, that is already the first question, so we can pop that in there. 98.05 meters. Lucky us. Awesome. Volume in concrete walls. That is our next question. Okie dokie. So question number 2. Volume of walls. I always like to write down what we're doing. Really, what it does is when I lose my brain and I forget what the heck I was doing, I can always look back and say, okay, that's what I was trying to figure out and go from there. It's really just present me helping future me when I get bamboozled. Well, any volume is length times width times height. Same here. So do we have a length? Well, yes, we do. We have the center line perimeter. That is literally the length of our wall. Our width will be our wall width, and our height will be our wall height. So it's pretty straightforward. Now we just got to pop in some numbers. So center line perimeter, we already figured that out, 98.05 meters times wall width. We already know that too, 0.3 of a meter times our wall height. We know that too, it's 4,200 mils. 1,000 is the conversion factor, so 4.2 meters. And again, punch her into the calculator. I like leaving previous numbers. Sometimes you get lucky and you get to reuse it, which is kind of nice. So 98.05 times 0.3 times 4.2 gets us 123.543. And now we're into cubic meters, right? Meters times meters times meters gives us a volume. And again, this is the volume of the walls. So that is the amount, the cubic meter number for how much concrete we're going to need to buy that's going to fit into the walls. In real life, always round up a little because you always need a little more. Wonderful. Look at us go. Breezing along. That is question number 2. So 123.543 cubic meters. Wonderful. Next is the volume in our concrete footings. And that goes the exact same way. So really it's just a repetition except for the wall numbers, we're using the footing numbers. So again, volume for footing, length times width times height. That is any volume calculation. And here again for length, we're using our center line perimeter. Our width is the 1050, so 1.05 meters. And our height is the 250 here, so 0.25 of a meter. And CLP, well, could have put in the 98.05. There we go. Then we can punch it into the calculator right away. 98.05 times 1.05 times 0.25 gets us 25.738 cubic meters, and that is the volume of the footing. Boom. That is question number 3, already answered. Right, there it is. 25.738 cubic meters. Wonderful. Okie dokie. Next, volume of our concrete slab. Okay, this one, not that it's convoluted or necessarily difficult, but we definitely have a few more steps for this one. So volume of the concrete slab. How do we figure that out? Well, like any volume for a slab, we need length times width times height. What happens here is that we're going to find the area of the slab, and any area is length times width, right? So length times width is already here, times our slab thickness. So now first we need to find the area of our slab. And the way she goes is that we take our nice and big rectangle, which is to the outside of the walls, right? The measurements. We minus jog number 1 and jog number 2. And we also have to take away the area of the wall itself. If you look at this down here, right, the measurement is to the outside of the wall, but the slab is butting to the inside of the wall. So outside the measurements minus the area of the wall will get us to the inside, and then minus our jogs here as well. So let's figure out what those are first. And all we need to do, because these measurements also go to the outsides, we can just multiply to find the area. So 5.85 times 15.125 gets us 88.481 square meters. And we'll call this jog 1. We'll call this jog 2. And we'll figure this one out as well. So 14.3 times 7.6. 108.68 square meters. Cool. And we'll remember those. Maybe I'll highlight them too. We'll need them a few more times in our calculations later. There you go. Easy to find. Perfect. So area of the slab. We take the area of the big, of all of it, minus the area of our jog number 1, minus the area of jog number 2, minus the area of our walls. And now we just get to pop in numbers. So area big. Those are our measurements from right here. So 27.525 I'm going to leave out the meters so it doesn't look so convoluted, times 22.1 minus jog number one. And just to show it once, I'll put them in here. So 5.85 times 15.125 minus jog number two, which is 14.3 minus 7.6 minus the area of our walls. Well, how do we find that out? Length times width, center line perimeter, which we, oopsie, which we already have, 98.05 times width of our walls is the 0.3. Groovy. Now we just punch them all into the calculator. And we'll do each bracket first. Yeah, just to show it. 27.525 times 22.1. 608.303. Right now we're into square meters. Jog number one, we already figured that one out. 88.481. Jog number two, we figured that one out. 8.68. And the area of the walls, 98.05 times 0.3. 29.415. Okay, now we punch it all back in to figure it out. 608.303.481 minus 108.68 minus 29.415. 381.727, and we're still in square meters because we just figured out an area. So that is the area of the slab. That is half of our what we had to figure out to find the volume of our slab. So let's find out the volume then. Volume, slab. Again, it's our area of the slab times thickness. And now we just punch in numbers. So 381.727 times, and the slab thickness is given to us here, the 120 times 0.12 meters times, and I left it in the calculator, times 0.12. Gets us 45.807. Now we're into cubic meters again. Right? Area times meters. Whoopsie, sorry, it's kind of hard to see. There you go. Gets us the volume of our slab. There we go. Boom. Easy peasy. So let's see. Volume of concrete slab, 45.807 cubic meters. Excellent. Great job. Cool. Alrighty, so what is question number 5? We want to find the volume of backfill underneath the slab. Okie dokie. I'm going to put this page aside because we're still going to need some of these numbers later, but just out of view a little bit. So volume, backfill. How do we figure that out? Well, we could potentially get very fancy because you can see that it's 400 mils deep up until the footing, and then it's thinner above the footing. We could get very fancy with this, but most likely we would round up anyways. And you compact it and you lose some here, there, and everywhere. So we're just going to make it easy on ourselves, which isn't wrong. We just end up adding a little bit extra, but it isn't a big deal. So we're going to find or use the area of our slab that we just figured out, and we're going to multiply by the height. of the backfill, and that's it. So area slab times height. Nice and easy. So area of the slab is what we just figured out. Here, maybe we'll highlight this here too in red. It's not a final answer from one of our questions, but we definitely need it. So that's this one. Right, the area of our slab. So we can just use that number, 381.727 square meters times 0.4. And part of math in these complex, long questions, or we answer several questions, is keeping organized because usually half of the questions you need some of the previous answers. So as long as you're keeping good track and you understand what you're doing, you can then find these numbers again so you don't have to double and triple do your work. Okay, so let's punch that into the calculator. 381.727 times 0.4 gives us 152.691. And that is cubic meters. So that's our volume of backfill under the slab. Groovy, right? That's much easier than you might have thought. Excellent. So we can pop that in here. 152.691 cubic meters. And let's see. Next, now we're into excavation questions. So here is the bottom area of the excavation. Now, the thing to remember here is that we have our big area, and you can see from this drawing here, oops, that we need the 600 mils working room all the way around the building. So we need to add that to our area. And you can also see that we have these jogs. So what ends up happening is that we figure everything out for the big rectangle, and we're just going to minus the area of the jogs. That's all we need to do. So bottom of the excavation, I like to draw myself a picture. This is the rectangle of our building. And this is our working room. As carpenters, usually we're visual people, so drawing things just makes them that much more clear. So the length is 27.525, and our width was 22.1. And we're adding, this is a common mistake, we're adding the 600 mils or 0.6 of a meter to all sides, right? Not just one side, but you need to double it up. So our length is 0.6 plus 27.525 plus 0.6. So we punch it into the calculator. Of course, you can go ahead and say 1.2, but just to show, and that's why I write it down like this, right? Working room on one side, then you have the length of your building, and you have the working room on the other side. So 0.6 plus 27.525 plus 0.6. 28.725, and we're in meters. Width, we do the same thing, but for the width, so 0.6 plus 22.1 plus 0.6. 0.6 plus 22.1 plus 0.6 gets us 23.3 meters. And these will come in handy a couple of times as well, so we'll underline them to help ourselves out for later. Great. So, area of the bottom. The way she goes is like this. Area, bottom, is area big, and that is including our working room, minus area of jog 1 minus area of jog 2. Okie dokie. So area of the big 28.725 times 23.3. And the areas of the jogs, we already figured them out and we wrote them in here to help ourselves out later because we're smart like that. 88.481 meters squared, and jog 2, 108.68 meters squared. And again, you can break them down and do one step at a time, or you can just punch them all into the calculator. So 28.725 times 23.3. We do want to know this one. Might need it again later. 293. Let's write them out again. Okay, now let's subtract 88.481 minus 108.68. 472.132. And we are in area. And this is the area of the bottom. Perfect. That is a number we'll need to remember. Oh, it's over here. So area of the bottom, 472.132 and meters squared. Now we need to do the same for the top of the excavation. Why do we do that? Well, eventually we want to find the volume of the whole excavation. And because the excavation is on a slope, it's kind of tricky to do it in one step. So we find the area at the bottom, we find the area at the top, and for the volume later, we'll add them together. So basically we'll get an average area, and then just multiply by the height, and that's how we'll get it. But first, the top area. Area top. Okay, so I like to draw myself a couple of pictures for this one. Again, just to visualize. Doesn't need to be perfect. So this is our regular from the bottom measurement, but plus the working room, right? Because that's what we're working with now. So 23.3, and we've got our 28.725. Okay, so we do know a number here. We do know that the slope is 1-to-1. That's what it says here. Slope's 1-to-1. And it also gives us the height. So it's saying that this, I won't write it down everywhere so it's not too much and clustered, but we do know that the height or the depth of the excavation is 3.45. So if it's ever on a worksheet for you not a 1-to-1 slope, we just figure it out with ratio and proportion. So our slope of 1-to-1, what we're trying to find out is this x number, right? We need to figure out how much distance is added here by creating that slope. So slope is 1-to-1. One horizontal to one vertical. And now we just pop in the numbers. So x is what we're trying to find out. And we do know the 3.45 vertical number. And now we just cross multiply. But it is a slope of 1-to-1. So we know it's going to be the same. But you would say 3.45, oopsie, 5 times 1. So you cross multiply to the top. And then divide by the bottom, which is also 1. So here we already knew x is going to equal 3.45. But if it was anything else, then that's how you would figure it out. Groovy. So let's figure out these lengths here. I'm going to squeak that in there. So we've got 3.45 plus 23.3 plus 3.45. Over here, we have 3.45 plus 28.725 plus 3.45. Right? Just adding the distance plus our number plus our distance, and we're doing that for the length and the width. Again, this is a common mistake to not do that everywhere, or just do it once instead of twice. So let's add them up. Plus, so 3.45 plus 23.3 plus 3.45. 30.2. And the other one, 3.45 plus 28.725 plus 3.45 gets us 35.625. Great. So now we have the new numbers that we need, right? Our new, whoopsie, that's not the right one. There. The new length and width. So the area for the top gets us the area of the big minus area of jog 1 minus area of jog 2, just like before. So the area of the big, I'll just write this in here in smaller, 30.2 times 35.625. So we can already figure that out. 35.625 times 30.2 gets us 1075.875. And we're in square meters, and the jogs are still the same, right? So we can still look up here or on our plans. 88.481 and jog 2, 108.6. Now just punch them in the calculator. So our area big from our new numbers, once we had added that sloped extra distance, that came out with a 1075 minus our jogs now. $878.714. And this is the area of the top. And again, square meters, right? Because it's an area still. Perfect. So that's the area of the top. Let's pop that in here. 878.714. Cool. So the volume of the entire excavation. Well, now that we've done volume a couple of times, it shouldn't be that foreign anymore. Neat. We've got volume of the excavation. Well, for this one, as I mentioned before, we take the area from the top and we add the area of the bottom and we divide them by 2 because we want to find the average, right? That's how you find the average of anything. You add the 2 together and you divide by 2. And then, of course, because it's a volume, we need to multiply it by the height. Height or depth of excavation, whatever words you want to use. So let's pop in some numbers. Thankfully, we have been keeping very good track, and we have the area of the bottom and we have the area of the top that we can just copy. So area from the top, 878.714 plus area of the bottom, 472.132 divide by 2. That is a terrible 2. And times the height. That's been given to us several times, right? The 3.45. And again, you don't have to put this all into the calculator at once, but you can. So we still have the number from previous, 878.714. That's the area of our top. So plus 472.132. You have to press the enter there if you're not adding brackets. Divide by 2, enter, times 3.45. Gets us 2330.209. And now we're into cubic meters again, right? Because we took areas and we multiplied by the height. That's not so bad, is it? And that is already our number. So let's pop that on our sheet. Volume of entire excavation, 2330.209. Cool. Okay, volume of truck away. So now we're just wanting to find the volume. Again, volume, so we need to find the area of just the building multiplied by the height. Well, how do we figure that out? Just like everything else before, we take the area of our actual building. So these measurements again, right? Not including the working room, actually of the building. And we're just going to take away jog 1 and jog 2 and then multiply by the height. And that'll be the amount of dirt that comes out of this excavation that will need to get hauled away. We don't have any bulking factors in this question, so we're just going to get the actual volume. Sometimes you'll be given a bulking factor like rocks or sand, where you have to multiply by 5% or 10 or 20%, because once it's dug up, it takes up more space than when it's nice and tight and snuggly in the ground untouched. Okay, so we're into number 9. We've got building volume, and this is the truck away part. That is terrible writing. I'm sorry. Okay, so there we go. Volume of the building. Well, same as before, right? So area big minus area jog 1 minus area jog 2. And we'll pop that all into a bracket and times the height. So we do need to figure out the area of the big, unless we already did, which I think we did. Look. Maybe we didn't. Let's figure it out. But it's easy to figure out, isn't it? We've got our numbers right here. Because we already know all of these numbers, I'll just pop these in here. So 27.525 times 22.1. Right? So we can already figure those out. What do we get? 27.525 times 22.1. There you go. 608.303. We're in area, right? So meters squared. Area of the jogs, still the same as before, 88.481 minus 108.68. Everything in brackets times our 3.45 meters, because that continues to be the height of our excavation or depth. Cool. So we just figured out this guy. So now we just got to subtract the jogs minus 0.481 minus 108.68. That's it. And then we'll write that down. 411.142. Point 3.45. Area of the building. Seems important that maybe we just keep track of that. Times 3.45 gets us 1418.438. Now we've multiplied by the height, so now we're into cubic meters, right? So volume of the building is that many. So with that number, we'll be able to figure out how many trucks we need to order to come take it all away. Okay, so we can pop that in 14, 18.438 cubic meters. Okay, so now the volume of backfill between the walls and the slope, huh? Okay, so let's see. Right, so we've got our whole excavation, everything on the slope. We just figured out the volume of our actual building. So most likely we'll be able to take the volume of our entire excavation, which we already figured out, minus the volume of the building will just give us the leftover volume, right, that we haven't accounted for yet. So while it may sound a bit confusing, it's actually not that bad. So this is the volume of the backfill. Right? We have the volume of the big excavation minus the volume of the building. And now we just copy down numbers. So 2330.209 cubic meters minus what we just figured out, 1418.38. Cool. So check this out in your calculator. You see that we still have that second number in our calculator. So I'll show you a trick in case you don't know it yet. So don't clear it. 2330.209 minus. See this little A and S for answer right here? It's on mine, it's in blue, which means if I hit the alpha button, that's also blue, and then this, instead of pressing enter, it'll pop in what's written in blue. So the answer of my previous question, so I don't have to punch it in again, and then enter. Cool. So that's the volume of our backfill. Punching things into the calculator is surprising how many mistakes everybody makes, including me. I usually have to do things several times because I just punch something in wrong. So sometimes by keeping numbers in there, it can be very helpful to just reduce that a little bit. Super duper. That is the volume of our backfill between the walls and the slope. So let's punch it in 911.771. Super duper, look at that. Only 3 to go. And it looks like we're done with all the volume calculations. So super yay for us. Lineal meters of 2x10 for footing forms. Okay, so what are we talking about? Lineal always means length. So our footing forms, the 2x10s will be on the outside here. And we need them on the inside and the outside. I know it's hard to see, but they just go on the outside, and that's just how footings are framed. It's pretty basic. So all the question is asking, how much total length of boards of 2x10s do we need to buy? And then at the store, they can say, oh, we have 16 footers, so we can divide it by the length of each board to find out how many boards exactly we need. But linear meters just means total length. Find a new page here. Okay. This is 11. We need lineal meters for the footing. Okay, well, do we know the length of our building? Well, we do, right? We know the center line perimeter, which we've used as the length factor for everything else so far. So that's exactly what we can do because the center line perimeter doesn't just run in the center of the wall, it also runs in the center of the footing. So here's the kicker. It's real easy. We take the center line perimeter, so the length, we multiply by 2 because we have it on the inside and on the outside. And that is it. So our center line perimeter, if I remember correctly, was 98.05 meters. Well, times 2. Sometimes the questions turn out to be quite easy when they sound complicated at first. Oops, here we go. Let's pop that in here. So 196.1 and meters, right? Lineal just means length. Okay, so contact area of formwork for walls. Cool. So we need contact area is a keyword here. We want to know how much area of formwork we basically need, which means we want to find out the area, the total area of our wall from the side, right? That's where the formwork goes. Again, though, it's not just on one side. Whoopsie, I'll pull this up a little. It's not just on one side because formwork is just like a glass of water. It needs to be on the inside and the outside, right? If we only have formwork on one side, all the concrete's just going to slough out and we're not going to have a wall. So how do we find out the area of anything? Length times width, right? So here we go. Number 12. Contact area walls. So area of walls gets us the length is the center line perimeter. We need to multiply by 2 because we want the inside and the outside. And then we need to multiply by the wall height, right? Length times width times 2 because both sides. So 98.05 times 2 times wall height, we know that already, 4.2. Cool. So 98.05 times 2, which coincidentally is that same number, times 4.2 gets us 823.620 square meters. And that's the answer already. 823.620 square meters because it's area. So now the last question is asking us the number of sheets of plywood, and each plywood has 2.97 square meters of coverage per sheet. So really we're trying to find the number of sheets. Well, we take the area of our walls that we just figured out, didn't highlight it. The area of our walls, and we just divide it by the area that one sheet covers. And that's it. So we can copy that number from above, 823.620 square meters, and the coverage is given to us of the 2 divided by 2.97 square meters. And again, look at that. The number is still in here, so just divide by 2.97 gets us 277.3. Can we buy 0.3 of a sheet? No, so we would want to round up. 278 sheets. And that's it. That's everything figured out. It's always easier to try and understand why you're doing what you're doing. The way I write things out, I do that on purpose, like I mentioned in the beginning. It's really easy for me to go back and find numbers and actually know what they mean because I lay everything out nice and clearly. And this is not just the way I lay things out for a video. This is how I actually do math for everything I do. It's present me doing a great big favor for future me, of just setting myself up for success. And then just remember, if you have questions like this, where you don't have a full rectangle, you can push out any walls to figure out your actual rectangle. And if you were to have any extra walls that you can't push anywhere, those just get added to your center line perimeter, like to your formula, right? Because you also need to fill them with concrete and you need formwork there, etc. And for excavations, you work with your outside rectangle and you just subtract the area of your jogs for depending what you need. And then just really have a good look at your drawings to see where do dimension lines go to, what are they trying to show, and where do things line up? You know, does the slab run into the wall or does it run into the footing? That greatly changes how you do your math, right? So that is it. I hope that was helpful.